Hopefully you've done this simulation for yourself already, but I want to point out a few things that hopefully you saw. So I've added this reference line up here. You can use that checkbox down here to do that. I just want to show how the amplitude is supposed to turn out so that we have a reference for when we add some things to it. Okay, so first of all, I sent a pulse. It's always going to be a triangular pulse, but there are different shaped pulses. In this case, we sent a pulse along the top, and before it reaches the end, this is what it looks like. It's a triangular pulse. Then when we let it go, it reaches the end, and when it bounces off the end, or when it returns from the end, now it's flipped upside down. Then once it reaches this end again, since it acts like another fixed end, it flips around again. So it seems like whenever it reaches a fixed end, it flips. Now let's try it with the loose end. So with this loose end, now this last molecule of the string, let's call it, is attached to a ring that's free to move up and down this bar. Okay, the amplitude is still the same. I've left it on the reference line. So now we're going to press play again. It's about to move this way. Well, let's restart it. Now we'll see what happens when it reaches the end. So it went toward the end on the top side and returned from the end also on the top side. So when it was a fixed end, when this piece couldn't move freely, then it returned, the pulse returned on the opposite side, on the underside of the string. Now, when that end is free to move, it returns on the upper side. Now let's try 2 pulses. So I'm going to send one pulse this way, and then once it reaches the end, I'm going to send another pulse. And we're going to try to see what happens when they combine. Actually, I want to do a loose end first. Here we go. Now it's hard to catch it exactly where it's supposed to be, but that's pretty good. So now both pulses are in the same place, and this is what would have happened the very first time we sent them. So the first pulse reached the loose end and then returned on the same side. The second pulse that I sent also was on the top side. And so now when they're in the same place, they add together. Okay, here's why I put the reference line in here. The reference line was the original amplitude of each individual pulse. When I send both pulses and they're in the same place, now the amplitude is about twice the size. Now we're going to try the same thing with a fixed end. So I'm going to send a pulse this way on the top, and once it reaches the fixed end, I'm going to send another pulse. Remember that the original pulse that I send is going to reflect back along the bottom. So what I'm trying to do is catch the 2 pulses when they're in the same spot. One when it's up here, and one when it's down here. Let's see how this goes. Now it's doing something strange in the middle, and I don't think that I'm going to be able to perfectly pause it in the middle unless I go slow motion. When they're in exactly the same spot, which I can't quite do, it just completely is a flat string. That's called superposition as well, except in this case it's called destructive superposition. Destructive superposition. The previous one, when we used the loose end, when they both ended up on top and they added together, that was called constructive superposition. Now I want to point out what happens after they have reached the middle. So we have a wave on the bottom encountering a wave on the top. They interfere with one another, which in this case causes destructive superposition. And then the 2 waves pass through each other, and continue on the side they originally came from. So we started off with a wave on the top side, moving this direction, and a wave on the bottom side, moving this direction. And when they encountered each other, they interfered, and then they didn't bounce off each other and return the way they came, they passed through each other, which makes sense when you think of waves as a transfer of energy. So if this wave is transporting energy from one side to another, it doesn't make sense that energy bounces off of another type of energy, right? Energy isn't matter. It's not something that can bounce. And so the energy that's moving along the top and the energy that's moving along the bottom, that total energy adds together when they reach the middle and then just passes through.